Recall that the human body only has 4 different types of tissues. There are epithelial tissues that line open spaces. There is muscular tissue that contracts. There is nervous tissue that conducts electricity. And then there is connective tissue, which we abbreviate as CT, and it does everything else that the other three don't do. Connective tissue, it has a variety of functions, and it's divided into 4 groups itself. There can be fluid connective tissues like blood. There can be loose connective tissues like adipose or fat. There can be dense connective tissues like a tendon or a ligament. And then there can be supportive connective tissues, which are cartilage and bone. All connective tissues can be thought of like a gelatin mold in which fruits are suspended. The fruits are these specialized cells right here. In bone, the primary cell type is called an osteocyte. However, there are other bone cells that also exist. The gelatin of a gelatin mold that comes in a powder form in the Jell-O packet, it's actually a mixture of proteins and water. Those proteins are meant to bind the water, which they do when you add hot water to them. But together, the watery substance and the proteins make up the gelatin. In connective tissues, we call the gelatin the matrix. I'm sure that name was applied well before that movie series came out. The matrix can contain only 3 different types of fibers: collagen, elastin, and reticular. It doesn't have to contain all 3. It can contain 2 or just 1. But those are the only 3 types of fibers available to connective tissue. So if you're on a lab and it asks you what type of fiber is in such and such connective tissue, your answer better be 1 or more of those 3 types of fibers I just met. Collagen, elastin, and reticular. The matrix is also made up of something called ground substance, which is kind of like an interstitial substance. Interstitial meaning between cells. And the interstitial substance or ground substance is very specific to each connective tissue. For example, in bone, the ground substance is made mostly of calcium salt. In blood, the ground substance is made mostly of water. Bone is rich in collagen fibers for strength. However, there are some elastin fibers that give bones their ability to twist and resist forces. However, both the ground substance calcium salts and the fibers together are what we would call the matrix. If we think of bone like a gelatin mix, then it's important for us to think of the proportion of that gelatin that's made up of protein and the proportion of that gelatin that's made up of water. And this would be analogous to comparing the content of collagen fibers in bone to the content of calcium salts in bone. As you can see, the calcium salts in bone are 2 times that of the collagen fibers present in bone. So the collagen fibers are part of the organic components. And down here, this is calcium, which is not an organic substance. Surprisingly, the specialized cells in bone, such as osteocytes and osteoblasts, is that it right here? I think it is. They make up only 2% of the bone that's present. When bone is being created in utero, collagen fibers are first secreted, and then the collagen fibers create a substance and then the osteoblasts create a substance made up of organic molecules that we call the osteoid. It's basically bone without the calcium salts. After the osteoid takes shape, then the osteoid is surrounded by those calcium salts. But as you can see from this graph here, some of the salts are made of potassium, sodium, and magnesium. So the process of depositing the calcium salts is called calcification. And calcification is only part of the original generation of your bone. In fact, making bone is called ossification, and the first step to that usually is calcification, both of which are discussed in another mini lecture. If we were to take one of your long bones, kind of like the femur here, and slice it in a frontal section, which is what this is a frontal section, creating an anterior and posterior part of the bone. But if we were to create this frontal section of the bone, we would see something like that picture there in the center. And as you can see, the bone is not a completely solid mass. In fact, a majority of the bone is made up of this porous type of bone called spongy bone. And spongy bone can take twisting, pulling, pushing from all different directions. Spongy bone is supported or surrounded by a denser form of bone tissue called compact bone. There we go. Compact bone is only on the superficial faces of long bones like this, giving the bone strength, but only in certain directions. Sometimes this is called the bone collar, because much like the collar of a shirt, this compact bone surrounds the spongy bone and gives it structure and support to maintain its shape. Many of the flat bones in your body are composed of a structure called diploe. Specifically, diploe refers to a flat bone. Actually, you know what? It refers to like a bone sandwich. But it refers to two flat bones that have spongy bone in between them. And this is what the bones of your skull basically have. They have two layers of compact bone with spongy bone in between them. And that is what is called diploe. I also wanted to mention that if your skeleton were created only of compact bone, that your muscles, as they are right now, would not be able to produce movement and move the bones. They would be too heavy for you to move. So unless your bones were made of compact bone, your skeleton be kind of useless because we would be unable to move.